Okay, so here we go with the homework, and you're welcome, by the way. There was no multiply, divide, add, or subtract. It is straight up analyze the function and give the wholes and all the different asymptotes. So we will start with number 1. Okay, so for me, I always try to factor anything I can possibly factor, okay? And the purpose for that's to find the wholes. So if I factor this, let me see if this is going to work. Plus 3 minus 1. Okay, great. This is how it factors. Now, as soon as I cross these two off, I know that there is a whole when x equals 1. And the one that's left in the denominator, that is going to be my vertical asymptote. Now, to analyze my horizontal asymptote, you do not have to go back to the beginning. You can if you want, or you can just look at what's left over here. In either case, the exponents match, and it's x to the first over x to the first, so you just have to reduce that and use the coefficients. So it's just 1 over 1, which is 1. And like I said, I wrote in the directions to look on a calculator to verify when you're done. I am not going to take the time to look on a calculator to verify. I feel pretty confident in myself when it comes to these, okay? So I'm going to go ahead and factor just in case. Actually, you know what? I'm not going to factor because I just did it in my head and they're not going to cross out. So there is no whole, okay? Not applicable. For a vertical asymptote, I'm going to set this equal to 0. And for my end behavior asymptote, I'm going to compare these, okay? So I've got negative 3x to the first over x to the first. So I can just reduce that and get y equals negative 3. So it's technically a horizontal asymptote in this case, not a slant, okay? Number 3. Number 3. Now, as I write this, I'm going to factor it as I write it, just to make things easier. Now, nobody's going to cancel, okay? Nobody cancels, which means no whole. And the vertical asymptotes would then be both of these, plus and minus 3. The end behavior asymptote, I need to compare the powers. So nothing canceled. It might be easier to look back at the original problem, and because you're really comparing an x to the first on top with an x squared on bottom. And since it's larger in the denominator, it will be y equals 0. So it's a horizontal asymptote there. And that's just the rule. Anytime it's bigger on bottom, it's 0. Number 4, same thing. I'm going to factor as I go. And it looks like this one's going to factor this way. On the bottom, let me take out a negative 3, which would then make this one, oh, that would be x squared minus 20. Minus 9, x plus 3, x minus 3. Okay, so lots of factoring can be done. None of it cancels, which means there is no whole. The vertical asymptotes would be at plus or minus 3 again for both of these. I wrote that wrong. It should have been, one of them should have been a minus, okay? And then my end behavior asymptote, I'm comparing the top to the bottom. Now, on top, I had an x to the third before I factored it. And on the bottom, I have an x squared. So x to the third, x squared. It's larger on the top. So what that tells me is that it's going to be a slant. And now I'm going to compare negative and positive like I told you earlier. So look back at that. It was an x to the third over a negative 3x squared. Well, when you compare those, it's going to be a positive divided by a negative. It's going to be a negative slope. That's what I want you to come away with. I don't necessarily need you to do the division and figure out exactly what the end behavior asymptote is. This is what they're going to want in calculus. Now, if you took the time, I don't want to discourage that, if you did take the time to find that, here's what you should have got. That would have been a negative 1/3 x And that would be it. Okay, that's like the remainder already. It has a remainder. So negative 1/3 x. So if you did that and figured that part out, more power to you. That's the exact slope of that negative slant. All right. Number 5. So we've got 4x plus 8 over this business. And then I'm going to try to factor this. Looks like the bottom is going to be x plus 2, x plus 3. Okay, great. I've just canceled out a factor, which does make there a whole at negative 2. The vertical asymptote is the denominator, x equals negative 3. The in behavior asymptote, if you want to look back at the beginning, it's an x to the first over an x squared. It's larger on the bottom, so it's automatically a horizontal asymptote at y equals 0. Number 6. These go pretty fast. I don't know how fast they went for you, but they should go pretty fast. Okay, I'm going to go ahead and factor this because I think it's like a 4 and a 3, a negative 4 and a positive 3. And if I factor the bottom, let me take a negative 4 out. And if I take a negative 4 out, it would be plus 1 minus 2, plus 1 minus 2, so x plus 2. Let me make sure that's right. X squared plus 1 minus 2, and that'll be right. Okay, this should be right. This is how everybody factors. There is no whole because nobody cancels. The vertical asymptotes would come from the denominator, and the in behavior asymptote would be, what was that? We were comparing an x squared over an x squared. So I need to reduce, and I would get negative 1/4 as my in behavior horizontal asymptote because you go with the coefficients, and that's what the coefficients were. Number 7, 1 over x plus 3. Okay, nothing factors, nothing cancels. No whole. I keep putting NA. You could also write the word none. If you wrote none, you're good to go. The vertical asymptote comes from the denominator. And the in behavior asymptote, well, you have a power of x to the 0. There's nothing there over x. So it's higher on the bottom. So it will be a horizontal asymptote at y equals 0. And our last one, I can't believe I'm already on the last one. These go fast if you are a good factorer. So I'm going to take out an x squared on the top. On the bottom, I'm going to take out a negative 2x. And what does that do for me? Okay, negative 2x, that's an x squared plus 5x plus 6. Okay. So that actually factors again into x plus 2, x plus 3. Okay, this is a good one. I love this problem. I bet that you got that, and you said, okay, there's a hole at negative 3. But I wonder if you caught this one. There's an x over an x, and there's no plus or minus attached, so you can cross out this with one of these. So since those canceled out, there is also a hole at 0, because that's the factor that comes with that. I don't know how many of you got that, but that is what would happen. Now, the only thing left in the denominator with a purpose is x plus 2, which means there's a vertical asymptote at x equals negative 2. And the in behavior asymptote, I'm actually going to go back to the beginning for that. I think they matched because it was x to the third and then negative 2x to the third. So it should be at negative 1/2 since they were matching powers. So if you looked on the calculator at the end of this one and you were like, oh my gosh, I don't know what's happening, probably because of that right there. The canceling of those causes things to switch places. So maybe you got it right, maybe you missed it. I don't know. We'll talk about it in tutorials. And then, like I said, I'm going to tell you why this is so critically important when it comes to calculus and some of the new vocab that you will be doing with respect to this stuff. So, later.